Does your website, obviously the Met website, does that get updated at specific times? You know, there's specific times that teams should report in during an emergency to have a look, or is it just again as things change?
It's partly as things change. Normally a severe weather forecast would be updated 2 or 3 times a day.
Mm-hmm.
Frequently it will be updated around 9 in the morning and then 9 in the evening. Every 12 hours there's a new run of the world's main computers that are doing the weather maps and trying to forecast what tomorrow's weather will be like. So we have a normal cycle of revising things at that sort of time period. However, if something goes on which is worse than we thought, sometimes you might find the weather radar picks up heavier rain than you'd originally planned, then you might do a new warning at an off scheduled time.
Mm-hmm.
But when that happens, you also, not only has it sent to the website, but we also will email a lot of people, and also there's a number of people in the regional councils that we will ring up and specifically say we've just updated the forecast. You should have an email and you can check the website and all that sort of thing.
Mm-hmm. Where does all your data come from? And obviously you're collecting it from specialised people that are out in the field, but are lay people collect data? You know, there's farmers that have their little Met service.
Well, it's the whole lot.
Do you get information from them as well? Or?
We certainly do with situations like snow, because with snow forecasting, it's a very fine balance between whether the precipitation falls as rain or falls as snow. It
Mm-hmm.
depends very much on how heavy the precipitation is. As soon as it starts to get a bit heavier, the cooling penetrates to a much lower level and it can change from rain to snow. So in the South Island particularly, we've got a lot of farmers who ring us up and will let us know if it has actually gone to snow. With other things like heavy rain, you've got the radars monitoring most of the country. We have a lot of stations on the ground where they used to transmit a message to us perhaps once an hour. A lot of them now send a new message in every minute.
Wow.
And we've got several hundreds of these all over New Zealand. In addition, the satellites coming in every hour with new photographs and information. So it's almost as if we've got too much information.
And can you see forecasting changing in the future?
The ways that it will change is that we're going to get more radars. So there are parts of the country at the moment that either get no radar coverage or they're on the fringe of the radars that are a long way away. When that happens, because the Earth's surface is curved, the radar doesn't get all the way down to the ground, so you just pick up the tops of the clouds. So we're improving that. We're also hoping to be able to use the new technology to do with communicating to people, so perhaps the forecast can be sent out faster. And there are new instruments that come along measuring things to do with the weather all the time, and so there could be other improvements that I don't know much about that could be just over the horizon. One of the ones that I've found most useful was the fact that satellites can now measure wind speed over the ocean, and that came on about 10 years ago, and no one had told me that was going to happen, and it was the most remarkable machine. It means that south of Australia all the way down to Antarctica, where perhaps we would have got only 1 or 2 ship reports a week, we now get thousands of wind reports every day. And those are also fed into the computers that are operating in the United States and the UK, modelling the entire weather systems of the world all at once. And they have improved significantly since this big gap in the data was filled by this instrument. And the computers themselves are forever getting more powerful and can resolve weather systems down to smaller and smaller scales. So my whole career has seen massive improvements in the technology, and I expect that to continue.
So are the weather patterns changing? When people talk about greenhouse warming, global warming?
Absolutely. One of the things that's been studied is the interest in global warming has led to much more scrutiny of climate. So again, during my career, we've seen a lot of knowledge gained about things like El Nino and La Nina. And they have quite a dramatic effect on the weather in New Zealand. And we've also noticed that although we have an idea that El Nino comes back about every 3 or 4 years, we've realised that there are also long-term cycles on the scale of about 20 odd years running through that pattern. Consequently, from about 1977 to about 1999, we had a lot of El Niños, and that meant a lot more southwesterly winds than normal, and our temperatures a bit cooler than normal. But since then we've gone into a situation where El Niños are not as frequent. So that's the thing that I think a lot of people in the general public will have noticed, that there's been a shift, not necessarily to do with global warming, and that has caused people to say, well, it didn't used to be like this. So there are things like that going on, but overall you have global warming as well, and that is doing things like increasing the sea level. So we expect to see more frequent weather events causing damage to the coastline and to roads and rail links near coasts. When you get that unlucky coincidence of a deep low with the spring high tide and the fact that sea level is going up. So we are living in changing times, and we expect to see that continuing.
Can we just have a little flick through your book? Yeah, hold it up there so we'll have a look at it. And so the information that's in there.
One of the things I like to do is relate the weather to the weather map. So there's that message about the wind going clockwise around a low in the southern hemisphere and anti-clockwise around an anticyclone. And that makes it easy for us to remember. If you're in Europe or the United States, the wind goes the opposite direction. When the lines are closer together, that's when you tend to get stronger winds. What you want if you're looking for rain is upward motion, and that tends to happen where you've got a low or a front, or in particular for New Zealand where you've got strong winds blowing from the sea into the hills, and that can increase the amount of rain you get by 10 or 100 times. So that's one of the things you look for in a sequence of weather maps: which part of the country will get wind from sea to land, where the fronts and lows are moving, and things of that nature. Also, you want to get some idea of where does the air come from. If the air's come from down near Antarctica, then you're likely to get colder than average. If the air's coming from the north, you're likely to get warmer than average. And so there's lots of different recipes like that. But also in New Zealand, with all the high hills and mountains, you know, a lot of places get their best weather when the wind is blowing across the mountains. So a weather map can look as if it's a bit threatening, but if you live perhaps in Canterbury on this occasion, you actually get warm weather and it'll be sunny, or there might be a bit of high cloud, but nothing much to worry about. And to some extent that's true in Wairarapa and Hawke's Bay as well. So especially in winter, there's a lot of places where the best weather happens when the weather map looks a bit threatening, but you're being rescued by the hills nearby.